In this video, we'll introduce the natural logarithm. The natural logarithm is usually denoted ln. In particular, the L stands for logarithm, and the N stands for natural. In fact, it's really logarithm natural, which is the French usage. Okay, so what kind of function is the natural logarithm? Well, it's the function that kills e's. It's the e killer. So what do I mean by that? Well, if you take natural logarithm and you apply it to e to the t, so I plug e to the t into this function, I get back t. I strip off the e. And that's very useful for solving equations involving exponential functions. For example, we may have an equation like this, and we want to figure out what t should be, and we need to strip off everything but the t. We need to take away the e, the 5, put it all on the other side. Well, to put the 5 on the other side, we simply divide by 5 as usual. Okay? But once we arrive at a situation where we just have the e on the right-hand side and some exponent, then now we apply the natural logarithm to kill off the e. Now, when we apply it, we have to apply it to both sides of the equation. So I take the natural logarithm of 10/5. I take the natural logarithm of e to the t. By this rule, that's the defining property of the natural logarithm, this is equal to t. So altogether, in other words, t is equal to the natural logarithm of 10/5. If you want, you could simplify that to natural logarithm of 2, which is about 6.9 if you plug it, 0.69 if you plug it into your calculator. Right, so it's important to note that you can't actually, there's no formula for the natural logarithm. The best you can do is sort of numerical approximations, and you can use a calculator to get these numerical approximations. Okay, there are some important properties of the natural logarithm that are very useful for exponential functions, and so let's list those. Well, already we've seen this property. That's sort of the beginning property, but associated to that is another property, which is this one, which says that if you use natural logarithm as an exponent, then e to the natural logarithm is t. In fact, these are the two defining properties, and it says that they say together that the natural logarithm is the inverse function for e. And we'll talk more about inverses later. But for now, we're just going to use these properties, plus we have the following properties. The natural logarithm of a product is the sum of the logarithms. And the natural logarithm of a quotient, or ratio, is the difference of the logarithms. Okay, in fact, these properties were used for many years to make multiplication simpler. Instead of having to multiply very large numbers, you can first convert them into a sum of logarithms that you looked up in a table, sort of what was used by navigators in, say, the 18th century or 17th century. The one other property that's very useful about the natural logarithm is natural logarithm of a to the t is simply t to the ln of a. Okay. A couple other interesting facts that you can derive from these important to be memorized formula are the following. If we take, for example, a to be equal to e, then we know ln of a to the t is ln of e to the t. So if a is equal to e, here we get ln of e to the t. We know that's equal to the t on one hand, and then over here we know that this is the same as ln of e. Okay, which tells me that ln of e is equal to 1. Okay, that's an important property. Another important property is gotten by plugging in t equals 0 into this relation. So we have ln of e to the 0 is equal to 0 if t is 0. But we know that e to the 0 is 1, so that's the same as saying ln of 1 is equal to 0. So that's an important thing to remember. The natural logarithm of 1 is 0. Altogether, all these things are very important properties that you should commit to memory. One last thing to talk about, which is the graph of the natural logarithm. The graph of the natural logarithm looks like this. Now we know that natural logarithm of 1 is 0, so we do know there's a x-intercept. And it can also be seen that natural logarithm is always increasing. Okay, it's concave down, and it's always increasing. So the graph looks like this. Notice there's no graph over here because the natural logarithm only accepts positive numbers. You can't put a negative number into a natural logarithm or any logarithm. Okay, this has been an introduction to the natural logarithm.